we find its speed at an instant? And while thinking about this, she had another strange thought. She was convinced that mathematically, the ball should never reach the floor. This thought has puzzled many people for centuries, and it's called the Zeno's dichotomy paradox. What are your thoughts about these problems? There were two more interesting problems we had discussed. Let's say we're standing on a cliff. Then, what is the best way to throw a stone such that it covers maximum distance? And the other problem was, how can we find the area of any shape, especially whose boundary is made up of curved lines? We know that calculus gives us the answer to all these problems. Question is, how? First, we'll focus our attention on these three problems. And for this problem, the one for which we need to find the angle at which to throw the stone, we'll have to wait till we gain some additional knowledge of calculus. Let's move on to a new page and start with this interesting thought puzzling Nora. She thinks that mathematically, the ball should never reach the floor. As the ball falls, it has to cover half of the distance between its starting position and the floor. Then it has to cover half of the remaining distance. Then it has to cover the next half, and then the next half, and so on. So the number of steps the ball has to perform never ends. Another way of saying it is that there are infinite number of steps the ball has to perform. Beware of the term infinite. Always remember that infinite is not a number. Infinite just means something which never ends or something that's limitless. Now, to perform each step, the ball takes some time. Since the number of steps the ball has to cover never ends, that is, there are infinite number of steps, so Nora thinks the ball should never reach the floor. But we know that as we drop the ball, it reaches the floor in a few seconds. So where is the mistake in Nora's logic? In order to know the time the ball takes to reach the floor, we have to add all the individual time periods taken to perform the individual steps. But to find this, we will have to add an infinite number of terms. Let's say we take our calculator out and start adding these numbers. Then our addition will go on and will never finish. And as we go on adding the number, the sum will get bigger and bigger. That's it. As the ball continues to cover the successive steps, the total time taken by the ball will keep on increasing. Another way to say this is the ball will take an infinite amount of time to reach the floor. But we know that this isn't true, as it's common knowledge that the ball will reach the floor in a few seconds. It will be a well-defined number. That means if we add all the time periods taken to perform the individual steps, we should get a number as our answer. Yes, even though we can't mechanically add the numbers, we can show that the sum of these infinite numbers is equal to a number. To show this, we carry out a process known as taking the limit. And this is the central idea that calculus uses.
Now, to know what is calculus, we need to understand the concept of limit. Okay. So, just I show one video. You can hear me, no?
Yes, ma'am.
Yes, ma'am. I wanted to show this video. Why do we learn calculus? So, such type of problems are there. That is T1 plus T2 plus T3 plus T4 plus etc. It is an infinite series, but you can see that it is approaching to a particular number. As the ball will reach at some time, there is a finite timing at which the ball touches the ground. Okay. So to this number, suppose it takes 2 seconds. So T1 plus T2 plus T3 plus etc. that infinite number, it is approaching to the number 2. That 2 is known as the limiting value of the series. So this just introduction of limit only. Last year I have studied what is the limit, right? So now we'll go to a function which is having the limit. There are different types of limit that you have learned last year: left hand limit, right hand limit. And if left hand limit and right hand limits are equal, then we say that the limit of the function exists. So just to see this one. There are many functions where limit does not exist. And there are functions whose one of the limits exists, that is left hand limit exists, but right hand limit does not exist. Can you this one? What is the name of the graph? F of x equal to x square, right? It is the parabola. You can hear, no?
Yes, ma'am.
F of x equal to x square graph. I'm taking a point from the domain. What is the domain of this function? What is the domain of this function? Again, we are going back to functions. What is the domain of the function? It is the real numbers. Okay. The domain is always taken from real numbers. So the whole real numbers you consider, and suppose you consider one point in the domain. That is this point I have taken as 2. Suppose 2 is a point, and we are going to find out the limit of the function at the point 2. To find the limit of the function at the point 2, what do you need to do? Limit x tends to 2 minus f of x. Means when x is taking value from left of 2, that means 2 say left side. When x is taking values left of 2, what is the function value? What is the function value? Function value, I have just shown it by using this red color line. Okay. So this y distance from this point to the curve, that is the function value. At the point 2, what is the function value? At the point 2, that means when x equal to 2, what is f of 2? F of 2 is, in this function also you can put f of 2 is 2 square. From the graph, f of 2 means this distance. That is 4. You can measure it in the y-axis. This distance is 4. So f of 2 is 4. So x is taken from the domain and f of x is the value of the function at the point 2. That is taken from y-axis. Okay. Now just to see what happens when x is taking values less than 2. Just to watch what is the value of x now. I have taken this x value now here. So these blue color points are x values. Here x value is -2 I have taken. Here x value is some 3 or something. Okay. See, just to see this x value is less than 2 value. When it is approaching to 2 from left of 2, what happens to the function value? This red color line, that is this length, is the function value at the corresponding point. Is to say x is approaching to 2, then about f of x is approaching. F of x value is coming nearer and nearer to this 4. Again, it is going back. Understood? When x is approaching to 2, this function value is approaching to 4. This is a function value. I'll show again. You just find out the nature of function value. You can see x is approaching to 2 from either side of 2. This one is right side. From right side, x is approaching to 2. Then f of x ka values here, it is written 5.5. It is approaching to which value? It is approaching to 4.
Download Byju's, the all-new and personalized learning app.
Will your child win free education for life? Book a free coding class with White Hat Tutor.
At negative values of x, observe that the value of the function decreases. Take a look at the function.
Okay, understood now? So when x approaches to 2 from right of 2, what f of x approaches to? When x is approaching to 2 from right of 2, you can see that blue wala point. This is x value, right? It is taken from domain. When x approaches to 2 from right of 2, you can see the function value here. Function value at this point, it is 7.76. And you see that it is getting reduced. It is getting reduced and reduced and reduced, and it is coming to 4. So when x approaches to 2, function value approaches to 4, we say that limit of f of x as x approaches to 2 is 4. So again, x is approaching to 2, f of x is approaching to 4. So this is what called right hand limit. Now you see the left hand limit. When x is approaching to 2 from left of 2, see now x is approaching to 2 from left of 2. There also you can see that the function value is approaching to 4. It is approaching to 4. So what we can say? The left hand limit, that is limit x tends to 2 minus f of x equal to 4. So these two things we have studied last year. If the left hand side limit of the function and right hand side limit of the function, if they are equal, then the limit of the function as x tends to 2 exists and it is equal to 4. So we can write that if these two are equal, the limit x tends to 2 of f of x equal to 4. This year what we are going to do is, you will just watch the function value at 2 also. If you watch the function value at 2, which is denoted by f of 2. f of 2 kya hoga? How to find f of 2? The function is f of x equal to x square and function is defined at 2 also. So f of 2 is 2 square. f of 2 is 2 square. From here you can take f of 2. f of 2 is 2 square. By geometrically also I am explaining, by algebraically also I am explaining, right? So f of 2 by algebraically, you in the equation you put x equal to 2, you will get f of 2, that is 4. And geometrically if you see, this is a value at the point 2. What is the perpendicular distance from the point to the curve? That is f of 2, that is equal to 4. So in this particular graph, all these values are equal. That is f of 2 is the same as limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x. In that case, we say that f is continuous at the point 2. f is continuous at the point 2. Okay. So let us say one more graph which I have made in GeoGebra. Here you see what is the function here? The function is f of x. Can anybody name this function by seeing the graph? Can anybody name the function? This is the equation of reciprocal functions, okay? Reciprocal function, f of x equal to 1 by x. This is I have written in the left side here, f of x equal to 1 by x. Now, I was just checking the limit of the function at x equal to 0. Limit of the function at x equal to 0. So to find the limit of the function at x equal to 0, see here, this right hand limit I want to check. Right hand limit means limit x tends to 0 plus. 0 plus means x is taking values greater than 0. From where do we take x value? From x-axis. Because the domain is always from x-axis or a subset of x-axis. Okay. So x is taking values right of 0 but very near to 0, then what happens to a f of x value, the function value? So here we can see geometrically what is happening. The function value, you can just look at this red color line segment, that's a function value. The point x I am taking as a blue colored one. This is not exactly the point, but just to make the concept clear, I made it like a circle. This, you just imagine that this is a point which is approaching to 0 from right of 0. Now, as this point approaches to 0 from right of 0, what this function value approaches? Just to see. Only look at the right side. This point is approaching, a function value is becoming larger and larger and larger. Okay. So again, you see, if it is coming here, it is becoming larger and larger. If it is x equal to 0.5, what is the function value? 1 by 0.5, 1 by 0.5. Then that becomes 1 by 2, or it is 2. When it is coming nearer and nearer, suppose here it is 0.3, then its value is 1 by 0.3. So that is becoming larger, right? So you can see here the value becomes larger. When it is very, very near to 0, you cannot even measure. It is larger than any real number on this, on the y-axis. So when a quantity is larger than any real number, we call that quantity as plus infinity. Any real number in the positive side of y-axis. It is larger than any positive real number here, right? So we call that quantity as plus infinity. So in this case, when x approaches to 0 from right of 0, f of x is very, very large. It is larger than any positive quantity on y-axis. We say that the limit of the function is, the function value is approaching to a very large positive quantity, and that large positive quantity, we call it as plus infinity. Or we say that you cannot define the positive quantity, then also we say that it is plus infinity. This infinity is not a particular number. It is any number larger than any real number. So it is not exactly defined. So it is plus infinity. So we say that limit x tends to 0 plus f of x is plus infinity. This and all last year I have studied. Now you just to see the left hand limit of the function at x equal to 0. What do you mean by left hand limit of the function at x equal to 0? Which is denoted like this. Limit x tends to 0 minus f of x. The 0 minus means it is not minus 0. It is 0 minus means you are taking values less than 0. That's the meaning. When x is less than 0, then what is the nature of the function value? Let us see. Now you look at left hand side of 0 on x-axis. This point D, it is a point from the domain. This is our x from the domain, and it is approaching to 0 from left of 0. Okay, when it is approaching to 0 from left of 0, you see this is a function value. Okay, what happens to function value? This function value, what is a function value here at this particular point? Let me see. See, when x is minus 1, what is a function value? That is also minus 1. This from geometrically we can say it is minus 1 because this distance is minus 1. Okay, algebraically how to find the function value? Here on left side you see function is f of x equal to 1 by x. When x equal to minus 1, The function value is 1 by minus 1. It is minus 1. Then again it's coming to minus 0.5. Then what is the function value? Minus 1 by 0.5. Minus 1 by 0.5 means it is minus 2. So when it is coming nearer and nearer to 0, from left side of 0, this length of this line segment is increasing, and it is when very near to 0, you cannot even imagine how small negative number it is. It is smaller than any negative number in the y-axis. So in that case, we say that it is very small, very, very small, or we say that it is smaller than any negative number on y-axis. That number we denote by minus infinity. It is not a particular number, so it is not defined. So the left hand limit of the function is minus infinity. And also one more thing you have to remember, that the limit is defined at a point. It's a point property of the function. We say limit of the function at a particular point. So what today we are going to learn is, if the limit of the function exists at a particular point, how to define continuity at a particular point. This point we always take from the domain of the function. So we are going to learn the continuity of the function at a point. We know only about the limit of the function at a point. The limit of the function at a point exists if the left hand limit of the function at that point and right hand limit of the function at that point both are equal and a finite number, then the limit of the function at that point exists. Now let us see what is continuity. Okay, children? One minute. Yeah.
Take a look at the functions and their graphs. Let's analyze the graphs. If we draw these graphs with a pencil, then we see that the first two graphs cannot be drawn without lifting the pencil. While the third graph can be drawn without lifting the pencil. It means that the first two functions are not continuous, while the third function is a continuous function. Mathematically, a function is continuous at x is equal to c if the function is defined at x is equal to c, and the value of the function at x is equal to c is equal to the limit of the function at x is equal to c.
Now you just write, children, this one. Continuity of a function. Please write. No need of drawing this graph. A function is continuous at x equal to c if the function is defined.
Wait, ma'am.
Yes? You can hear, no? Please write down the definition. A function is continuous at x equal to c if the function is defined at c and limit x tends to c f of x equal to f of c. Have you written the definition? A function is continuous at x equal to c if the function is defined at x equal to c and limit x tends to c is equal to f of c. You can see that this continuity is a limit, sorry, it is a point property. Now listen.
Let's interpret these graphs by determining the left and the right-hand limits of each function. Let's start with the first graph. It is clear that the value of the function is equal to 2 for all negative values of x. This implies that at all points near and to the left of 0, like minus 0.01, minus 0.001, minus 0.0001, and so on, the value of the function is 2. Thus, we can say that the left-hand limit of f at 0 is 2. Similarly, at all points near and to the right of 0, like 0.01, 0.001, 0.0001, and so on, the value of the function is 3. Thus, the right-hand limit of f at 0 is 3. The value of f at x is equal to 0 is 2. Observe that the left-hand and right-hand limits do not coincide. Also observe that the value of f at x is equal to 0 coincides with the left-hand limit. Therefore, the function is not continuous at x is equal to 0. Next, consider the graph of the second function. In this case, the left-hand limit and the right-hand limit of function f are both 2. However, the value of the function at x is equal.
Just look at the graph. This graph function is defined as f of x equal to 2 if x not equal to 0 and is equal to 1 if x equal to 0. Now what will be the left hand? We are talking about the limit at the point 0. Tell me what is the domain of this function? What is the domain of this function? Hello? Bhuvan, tell me, Bhuvan.
Yes, ma'am.
What is the domain of this function which is displayed?
R.
Yes, very good, R. The x values are called domain of the function. You just look at the function which is defined in,
Let's phrase
that is x not equal to 0 and x equal to 0. Uska matlab x ko all the values are there. When x is non-zero real number, the function value is 2. When x is 0, then the function value is 1. That means in the real axis, in the x-axis, all the values are taken for x. X is taking all the non-zero value and x is taking the value 0 also. Okay. So the domain is all real numbers. Now when x is not equal to 0, means the right side of 0, all the positive side of x-axis and negative side of x-axis, the function value is 2. So when function value is 2, you know that is a constant functions graph. It is 2. It is parallel to x-axis, which is 2 units away from x-axis. And when x is equal to 0, what is the value? It is 1. How do we draw the graph when x equal to 0? You are getting only 1 point. When x equal to 0, you are getting 1. Means x ka value 0 hoga, y ka value 1 hoga. So 0, 1 point. So ये graph को 3 part है. One is this side, and this. Now what we are going to check is the continuity of the function at x equal to 0. For that, what do you need to check? Whether the right hand limit of the function at x equal to 0, left hand limit of the function at x equal to 0, are they equal? If they equal, it should that equal quantity must be equal to f of 0 also. So what we are going to do next is to find the left hand limit of the function at x equal to 0. How do we write that? Limit x tends to 0 of 0 minus of f of x. 0 minus means x is taking values less than 0. So we are going to find the left hand limit of the function. How do we find left hand limit of the function? Limit x tends to 0 minus what is f of x? When x is less than 0. When x is less than 0 means negative side of x-axis. That means from the algebraic form, you look at here where x less than 0 lies. When x less than 0 will be included in the first part. X not equal to 0, right? X not equal to 0 का मतलब x less than 0 भी इसमें है, x greater than 0 भी इसमें है. So x less than 0 में function value 2 है. And limit of 2 आएगा. Limit of 2, last year I have studied, limit of the constant is constant itself. So limit of 2 will be 2 itself, okay? Similarly, now you find the right hand limit, children. All of you write down and find a right hand limit of this function. That is, you have to write limit x tends to 0 plus f of x. Please find right hand limit. I hope you might have find out. I'm just again starting the video. Okay, look at the video now. Look at the video now.
Here also, the value of the function at x is equal to 0 is not equal to the left-hand limit and the right-hand limit. Hence, this function is also not continuous at x is equal to 0. Now observe the third graph. In this graph, the left-hand limit.
See here, what is the conclusion here? The left-hand limit and right-hand limit, they are equal, right? So the limit of the function exists. But what is the third condition? That limiting value must be equal to f of 0, function value at 0. For checking the continuity, 3 things you have to check. First is left-hand limit of the function at 0, right-hand limit of the function at 0. If they are equal, limit exists. That's the first thing. Then next you have to go for the function value at 0. Function value at 0 from the equation of f of x you will get. How? What do you mean by function value at 0? It is f of 0. F of 0, how do we get? F of 0, the meaning is that the function value at x equal to 0. When x equal to 0, the function value is 1. So f of 0 is 1. So we can see that this f of 0 is not equal to this. Therefore, the function is not continuous. Let us go to the next graph.
The right-hand limit and the value of the function at x is equal to 0 are all equal to 1. Hence, we can say that function f is a continuous function at the point 0. Let's phrase the definition of continuity. Suppose f is a real function on a subset of real numbers, and c is a point in the domain of f. Then f is continuous at c if the limit of f of x as x approaches c is equal to f of c. If f is not continuous at x is equal to c, then we say that f is discontinuous at c. At c is called a point of discontinuity of function f. Let's apply the definition of continuity to check the continuity of a function f given by f of x is equal to 3x plus 1 at x is equal to 1. It is clear that the
Now what you have to do for this? Let us check the continuity of. You have to check the continuity at the point 1. Here you are given only f of x equal to 3x plus 1. Then what is the domain of the function? When it is nothing is defined, nothing is given separately, it is understood that it is a real function. Means the whole real numbers will be there. Okay. So the x values are any real number. And you are going to check the continuity at one point on the domain. That point here is x equal to 1. So this is very important that we are going to check the continuity at a particular point. That point here is 1. Now to check the continuity at 1, we have to go to the definition of continuity. What's the definition of continuity? Left hand limit at 1, right hand limit at 1 of the function f of x is equal to f of 1. How to find f of 1? F of 1 is in the algebraic equation, you put x equal to 1, you will get f of 1. Now, how to find the limit of the function? Limit of the function at x equal to 1. Now, naturally one question arises here. Do we have to go for LHL, RHL always to find the limit? It is not necessary to go for LHL, RHL because here the domain is not splitted into two intervals. Domain, the previous case, you can see that when x is not equal to 0 and x equal to 0, two different values of functions. When there are two different values of the function, then only we have to go for LHL, RHL. Suppose at less than 1, x less than 1 में एक function value है, x greater than 1 में दूसरा function value है, then only we have to go for LHL and RHL. Now let us watch this video again. So we are going to check the continuity at x equal to 1. Please write the question. Check the continuity of f of x equal to 3x plus 1 at x equal to 1. Write down the question, children, all of you. Now you listen. Look at the screen and listen.
The value of the function is 4 when x is equal to 1. Next, we'll find the limit of the function as x approaches 1. This is given by limit of 3x plus 1 as x approaches 1. This is equal to 4. Thus, the limit of the function coincides with the value of the function. Hence, the function is continuous at 1. Let's now check the continuity.
Please write down this. Students, please write down. See, one thing I'll tell you, here we have not gone for LHL, RHL. Here in this step, we are trying to find the limit of the function at x equal to 1. We are directly writing limit x tends to 1 of f of x equal to limit x tends to 1 of function value kya hai? 3x plus 1 that you are putting, and last year I have studied that limit of a polynomial. This is a polynomial of degree 1. How to find the limit of this? You simply replace x by this 1. You will get the limit. Once if you are writing limit, again you don't write limit here, okay? So the limit, to get the limit of a polynomial, you replace x by 1 in the polynomial. So 3 into 1 plus 1 equal to 4. Now, the question is, why don't we go for LHL, RHL? When x less than 1 and x greater than 1, in all the cases, same function value hai. On just above 1 and just below 1, same function value, there you can find the limit directly. Only limit x tends to 1 you have to take. If it has got different values on either side of 1, that is function value is different, then only you have to go for LHL, RHL. So the limit you have got 4 and the function value at 1 also, f of 1. F of 1 means x equal to 1 dollar function mein, then that also 4. So both are equal. Therefore, f is continuous at x equal to 1. Please write down. You can expect one question in the board also regarding continuity. Now look at the screen and let us go to the next video.
Ma'am, time.
Check the continuity of function f of x as shown at x is equal to 2. From the definition of the function, it is clear that the value of the function at x is equal to 2 is 6. Next, the limit of function f of x as x approaches 2 is equal to 7. Here, we see that the limit of the function and the value of the function at x is equal to 2 do not coincide. Hence, the function is not continuous at x is equal to 2. Let's now check the continuity of the function f of x. Let's now check the continuity.
I hope you might have understood this. Here we have got two function value, but we have to check the continuity at x equal to 2. So do we have to go for LHL and RHL for finding the limit at 2? Limit at 2, how to find? You just look at the function, just less than 2 and greater than 2, whether we have the same function value or not. Here in this, x equal to 2 and x not equal to 2. When you take x not equal to 2, उसका मतलब 2 छोड़कर बाकी पूरा रियल नंबर है. उसका मतलब x जब less than 2 में भी 2x plus 3 है, x जब greater than 2 में भी f of x is 2x plus 3. So on either side of 2, the function value is same. So you need not have to go for LHL, RHL. You can directly find the limit. Limit x tends to 2, f of x equal to limit x tends to 2. F of x का correct value select करो according to question. So it is 2x plus 3 when x is approaching 2. Now one more thing last year I have learned. X approaching to 2 or x tends to 2. इसका मतलब x is coming closer and closer to 2 on either side of 2. But x is never equal to 2. So when x approaches 2, how to find which is the correct function value? X approaches 2, matlab x not equal to 2 hai. So when x is not equal to 2, what is the function value? 2x plus 3. This is a way you have to select or choose the correct function value from the question. Now we write down. And this is a polynomial. So limit is limit of the polynomial. How to find? ये जो polynomial में जहां जहां x है वहां दुको x equal to 2 डालना है. So you will get 2 into 2 plus 3 that is equal to 7. And f of 2 का मतलब f of x when x equal to 2 है वो equal to 6 है. So are they equal? They are not equal. So the function is not continuous. A function when it is not continuous is known as discontinuous function.
With Byju's app, children remember their concepts forever.
Please write down.
Hello, everyone. In this lockdown, the world might have stopped in its tracks. But my children,
At negative values of x.
Okay, now look at the screen.
Let's now check the continuity of the function f of x. Let's now check the continuity of the function f of x is equal to sine x in the closed interval 0, pi. The graph of the function in the closed interval is shown. It is clear from the graph that the function is continuous at every point that lies between 0 and pi. However, if we say that function f of x is equal to sine x is continuous in the closed interval 0, pi, then we need to show that it is continuous at every point in that closed interval. So let's check the continuity of the function at its endpoints. The right-hand limit of f of x at x is equal to 0 is 0, which is the value of the function at 0. The left-hand limit of f of x at x is equal to pi is also 0, which is the value of the function at pi. Hence, the function is continuous at the endpoints. Here, we do not need to find the left-hand limit of the function at 0 and the right-hand limit of the function at pi. This is because the points left to 0 and right to pi do not lie in the given domain. Thus, mathematically, a real function f is said to be continuous if it is continuous at every point in the domain of f. Let's study the nature of the function. F of x is equal to 1 divided by x as x approaches to 0 from the right. That is, we intend to find the right-hand limit of the function f of x at 0. This table shows the values of f of x for different values of x. When x is equal to 1, f of x is also equal to 1. The value of the function at x is equal to 0.5 is 2. The value of the function at x is equal to 10 raised to the power minus 1 is 10. The values of the function at other points are as shown. Observe that the value of the function increases as the value of x comes closer and closer to 0. This implies that for a positive real number very close to 0, the value of the function will be a large number. This number is larger than any given real number, which is represented as shown and is read as plus infinity. Therefore, the right-hand limit of the function as x approaches 0 is plus infinity. Plus infinity is not defined. Hence, we can see that the right-hand limit of the function f of x at 0 is not defined or does not exist. Now, let's check for the existence of the left-hand limit of the function at 0. Let's discuss the nature of the function. F of x is equal to 1 divided by x as x approaches 0 from the left. Let's observe the table that shows the values of the function at negative values of x. Observe that the value of the function decreases as x comes closer and closer to 0 from its left side. This implies that for a negative real number very close to 0, the value of the function will be a very small number. This number is the number smaller than any given real number, which is represented as shown and read as minus infinity. Therefore, the left-hand limit of the function as x approaches 0 is equal to minus infinity. Minus infinity is not defined. Hence, we can say that The left-hand limit of the function f of x at 0 is not defined or does not exist. The graph here depicts the graphical representation of function 1 divided by x.
I have already shown you the graph. Anyway, you look at the graph.
Observe that the graph of the function is very close to the y-axis as the value of x approaches 0 on either side of the y-axis.
I hope you understood this, children. This is another one. F of x equal to tan x graph. We just observe that the values of x and the function values are shown in this table.
Let us now consider another function.
And just observe the function values. Observe the function values as x values are approaching to a particular value. Which value x approaches to is 90. So all the values cannot be shown in this table, but in the graph you can just imagine that x is approaching to approaching to 90. From which side of 90? As per the table, it is left side of 90, right? Less than 90 values taken. So left side of 90 when it approaches, what the function value approaches to. Just watch.
The table here shows the values of tan x for different values of x close to 90 degrees from its left side. It is clear from the table that the value of tan x increases largely when the value of x approaches close to 90 degrees. This implies that for an angle very close to 90 degrees from the left side, the value of the function will be a large number. This number is a number larger than any given real number and can be represented by plus infinity. Thus, we can say that the limit of tan x as x approaches 90 degrees from the left is equal to plus infinity. Take a look at this table now. It shows the values of tan x with respect to the values of x close to 90 degrees from its right side. It is clear from the table that the value of tan x decreases largely when the value of x approaches to 90 degrees from the right side. This implies that for an angle very close to 90 degrees from the right side, the value of the function will be a small number. This number is smaller than any given real number and can be represented by minus infinity. Thus, we can say that the limit of tan x as x approaches 90 degrees from the right is equal to minus infinity. Hence, the limit of tan x as x approaches 90 degrees does not exist. Consider two real functions, f of x and g of x, continuous at real number c. What can you say about the continuity of the sum? Difference.
So I'm just stopping the video now. Let us go to the textbook questions. Today what we have learned is that f is continuous at a point C. Now one more thing I have to write that if f is continuous at every point in the domain, then the function is said to be, if f is continuous at every point in the domain, then it is said to be continuous curve. The function is said to be continuous if it is continuous at every point of its domain. Please write children, continuity of a function in the domain. Underline. If F is continuous, sorry, time is over, I think, no? So this is if you just write down and stop it. If F is continuous, at every point of its domain, then F is said to be, a continuous function. And F is said to be a continuous function. I have prepared some textbook questions also. I could not do it. I was not noticing the time. Sorry very much. I've taken too much time. What is the next period? Thank you, children. Bye-bye. The rest, okay? Sorry for extending that. I should have reminded me. I didn't have the watch present.